All right, so for this video, we are talking about factoring to solve using GCF and trinomials where a equals 1. So we've kind of already talked about factoring a little bit, but we can actually use factoring to solve quadratic equations. And the reason we can do that is because of the zero product property. So you may have seen this before in Algebra 1, but the zero product property tells us that if two factors multiply to equal 0, so you have two factors that equal 0, that means one or both of your factors must equal 0. So we are able to solve by setting each factor equal to 0 and then solving both of those equations. So both of these examples here kind of lay out setting them equal to 0 and then solving to find your two answers. So that's what we're going to do here for this video. We're going to do that by GCF and by trinomials where there is no value in front of x squared. So starting with our GCF problems, this means we're looking for a greatest common factor that we can divide out in order to solve. Before we can do that, we have to make sure that all of our terms are on one side first, so that we have all of our terms and then they're equal to 0. So our first problem already has that for us. So then we're just looking for the greatest common factor that goes into 3x squared and 12x. So for us, our GCF for this problem would be 3, because 3 goes into 3 and 12, and then x, because there's an x in both terms that I could divide out. So that means I'm dividing both terms by 3x, which factors that to the outside, and then what's left is what goes in my parentheses. So 3x squared divided by x, 3x, 3 divided by 3 is 1. X squared divided by x, meaning you had two x's and you divided one of them out, so you're left with 1x. Then I have plus 12 divided by 3 would give me 4. And then I had an x, but I divided it out, so there's no x left in that term. So this is the factored form when we factor out our GCF. So now to solve, I'm going to take both terms, and this is included as a term. So I'm going to take this and set it equal to 0, and then I'm going to take x plus 4 and set it equal to 0. So when I solve this, I would be dividing both sides by 3 to get x by itself. So when I divide by 3, that would just give me x equals 0 for this term. And then here, I would be subtracting 4 to get x by itself, so I get x equals -4 as my other answer. So now for number 2, before I can solve, like I said before, you have to make sure all your terms are on one side. So I can move either term, it doesn't matter, but I'm going to move this term because it's smaller onto this side. So to do that, I would just be subtracting 4x to both sides. So now I have 8x squared minus 4x equals 0. And now I can factor out a GCF because I have it equal to 0. So my GCF between 8x squared and 4x would be 4x, right? A 4 can go into 8 and 4, and then they both have an x term that I could factor out. So my GCF is 4x. So that means I can divide both terms by 4x, which puts my 4x on the outside. That's what I factored out. And then what's left when I divide goes inside my parentheses. So 4x squared divided by 8x squared, divided by 4x would give me 2x. 8 divided by 4 is 2. I had two x's. I divided one of them out, so I'm left with 1x. And then 4x divided by 4x would just leave me with -1. So then to solve, I take both of my factors. So 4x is a factor. So I take 4x and I set it equal to 0. And I take 2x minus 1 and I set it equal to 0. So then I would get that my answers are x equals 0 and x equals 1/2, right? If I add 1 to both sides and then divide by 2, I would get 1/2. So go ahead and pause this video and try number 3, and then we'll go over the answer together. But go ahead and pause this and try number 3 on your own. Okay, so hopefully you paused the video. And you tried this problem, so you should have gotten that your GCF was 5x squared. When I divided out the 5x, or factored out the 5x squared, I had 5x squared times x plus 3. So then I set 5x squared equal to 0 and x plus 3 equal to 0 to solve, right? If I was just asking for factors, there wouldn't be an equals 0, and this would be my factored form. But since there's this equals 0, that means it's asking me to solve. So then I put these two equal to 0, When I solve this, I get negative 3. When I solve this, when I divide by 5, I would get x squared equals 0. So then to solve an x squared, that's like the square root problems that we've been going over. If I square root both sides, I'd get x equals plus or minus 0, but there is no such thing as a plus or minus 0, so my answer here is just 0. If it was any other number, like a 3 or something, then you would get plus or minus, but because you have 0, we don't need to include the plus or minus in this problem. Okay, so hopefully that was a good refresher on greatest common factor and then also how to solve with our greatest common factor. So now we're going to review factoring when a equals 1. So you should have seen this in Algebra 1 a lot. All we're going to do is come up with the two factors that multiply, that if we would FOIL back together to give us this. An important note, remember we have to make sure that all of our terms are on one side first before we solve. But once they are, so for instance, this problem already has it equal to 0. I need to come up with my two factors that the last terms multiply to give me 24 and add to give me 10. So it's going to look like this. So I need two numbers that multiply to give me positive 24 and add to give me positive 10. So if you think about your factors of 24, 2 and 12 wouldn't add to give you 10 though. Positive 8 and 3 would add to give me 11. So I would find that 4 and 6 would multiply to give me 24. And I need positive 24. So that either means both of my numbers need to be positive or both of my numbers need to be negative. Since this piece is positive, that means that these two both need to be positive as well. So then I get x plus 4 and x plus 6. If you weren't sure if you had it right, you can always FOIL it back together to make sure that you have the right terms. So you end up back here if you would FOIL this together. So once I've factored it, then just like our zero product property tells us, I'm going to set both terms equal to 0 to solve. So I end up with x equals negative 4 and x equals negative 6 as my two answers when I solve. So we're not only factoring, we're now factoring to solve. So once we factor, we set them equal to 0 and we solve. So if we look at number 5, remember the first thing we need to make sure is all of our factors are on one side. So I need to move this negative, or we need to move this 7x to the other side, which means we're just going to subtract it over. So I get x squared minus 7x plus 12 equals 0 when I move that. So now I need to factor. So I need two terms that multiply to give me 12 and add to give me negative 7. So the fact that they multiply to give me a positive and add to give me a negative would mean that both of my terms are negative, right? Because a negative times a negative would multiply to give me a positive and add to give me a negative. So then two numbers that multiply to give me 12 would be 4 and 3. And those add to give me negative 7, right? Negative 4 plus negative 3 would give me negative 7. Negative 4 times negative 3 would give me positive 12. So we want to make sure that we're also getting those signs correct to give us those two numbers. So then just like before, I would set both of my factors equal to 0 in order to solve. And I end up with x equals 4 and x equals 3. So for number 6, we're going to do the same thing. First, we're going to move this over so that all of my terms are on the same side. So I get x squared minus 2x minus 35 equals 0. So now I want to factor this so that I can solve. So I want two numbers that multiply to give me negative 35 and add to give me negative 2. Because this is negative, when I multiply, that means one of my terms is positive and one of my terms is negative, right? A positive times a negative gives us a negative answer. So then two numbers that multiply to give me 35 would be 7 and 5. So then if I want my 7 and 5 to give me a negative 2, I need this to be negative 7 and positive 5, because negative 7x or negative 7 times positive 5 gives me negative 35, but then I need a negative 7 plus 5 to end up with a negative 2. If these signs were switched, I would have positive 7 and negative 5, which would give me a positive 2 here. So we got to be careful that our signs are correct to meet both needs. They multiply to give you the last term and add to give you the middle term. So now I can use this to solve. So I set x plus 5 equal to 0, and x minus 7 equal to 0, and that would tell me that x equals negative 5 and x equals positive 7. All right, so go ahead and try 7, 8, and 9. Something to talk about with number 8 is there's no x term, so you can take this as x squared plus 0x minus 36. Since there's no middle term, that means that they added to give you nothing. So you could write 0x if that helps you factor. But go ahead and try 7, 8, and 9, and then we'll check our answers once you're done. So pause that video and try those. All right, so if you pause the video to try these problems, these are the answers that I would have ended up with. So on this problem, I had to subtract my 56 first so that my entire trinomial was on the same side so that I could factor. When I did that, to multiply to negative 56 and add to give me negative 1, right? There's an imaginary 1 here. So that would be negative 8 and positive 7, which means that when I set those equal to 0, I get that x equals 8 and x equals negative 7. So then for number 8, when I factored, I needed something that multiplied to give me negative 36 and added to give me 0. So remember, to get a negative 36, that means one term needed to be positive and one term needed to be negative. So 6 times negative 6 gives me negative 36, and then 6 plus negative 6 would give me 0. So I get that x plus 6 equals 0, x minus 6 equals 0. So my answers are 6 and negative 6, or plus or minus 6. And then for my last one, to multiply to give me 25 and add to give me 10, I needed x plus 5 and x plus 5. And then because these two are the same, when I set them equal to 0, I really only end up with one solution. I end up with negative 5 as my answer. All right, so hopefully that was a good refresher on factoring. That should have seemed kind of familiar, the factoring piece, and then to solve, we're just setting equal to 0. So now in these last couple problems, we're just putting these two pieces together. So first, let me turn the lights on. There we go. Now that the lights are on, we're going to start by factoring out our GCF. So in any time we're factoring, we always want to look for a GCF first. If we can take the GCF out in order to simplify, that'll make the problem easier, and then we can factor what else is left. So if we look at number 10, the first thing I'm going to want to do is move everything to the same side. So if I move my 90 over, I have 2x squared minus 8x minus 90 equals 0. So now, before I start factoring, I always want to check to see if there's a GCF that I could factor out. So in this case, between 2x squared, negative 8x, and negative 90, they're all even numbers. That means I could divide a 2 out from each term. That's just going to make factoring easier for us. So when I divide out that 2, I get x squared minus 4x minus 45. And now I can factor x squared minus 4x minus 45. So what multiplies to give me negative 45 and adds to give me negative 4. That would be x minus 9 and x plus 5. So now when I set all of these terms equal to 0, when we did GCF, I told you to set what was in front, that factor in front, equal to 0. Well, if I try to set 2 equal to 0, there's actually nothing to solve here. Since there's no x term, this is not going to produce a solution, right? If I try to set 2 equal to 0, that's not a true statement. So there's no solution that's going to come from there just being a number in the front. When there is an x in the front, we want to make sure we're setting it equal to 0 to solve and get a value for x. But since there's no x in the front, there's no value that you're solving for. There's no x value that you're solving for here. So really, I'm just wanting to know when x minus 9 equals 0 and x plus 5 equals 0, right? I set both of my factors equal to 0, which tells me that x equals 9 and x equals negative 5. All right, for my next problem, I don't need to move anything over. I already have it set equal to 0. So now the first thing I want to do is check for a GCF. Is there something I can divide out of each term? So number-wise, there's not. There's nothing I could divide 1, 9, and 14 by that's going to make this smaller. However, each term has an x in it, so I could divide out an x. So if I divide an x out of each term, that puts an x on the outside that I factored out, and then I get x squared plus 9x plus 14, and now I can factor this just like I was doing up here. So it multiplies to give me 14 and adds to give me positive 9 would be positive 2 and positive 7. So now when I set each factor to 0, this x has a value out here, right? I can set that equal to 0. 2 I could not set equal to 0, but x I can. And that tells me one of my solutions is x equals 0. Then I'm going to set, okay, sorry, I got interrupted, so I actually don't know where I left off in this problem, which is fine. But let's just, whatever I said before, I might repeat myself, sorry. But we know that our x equals 0 because this is a factor, it has an x value, so I need to set this x equal to 0, unlike the 2 doesn't have a value of x. I'm not looking for a value here. So then I'm just going to set these last two terms equal to 0 to solve for my last two solutions. So this would tell me that x equals negative 2 and x equals negative 7. So I actually have 3 solutions to this problem: 0, negative 2, and negative 7. All right, for number 12, I'm going to first move everything to the same side. So I'll move my 33x cubed over. So I have 3x to the 4th minus 33x cubed plus 84x squared equals 0. So then this seems like a lot to factor, but if we take a GCF out first, it's going to really simplify it and make it easier. So my GCF here would be 3x squared. I'm going to write that up here just so I have room to solve. 3x squared, right? I know this divides by 3 and this divides by 3. I could check really quickly and make sure 84 divides by 3 to make sure that that's part of my GCF. And then each of these terms has an x squared, right? My lowest x value is x squared, which means I can divide all my terms by x squared. So when I do that, 3x squared, 3x squared, 3x squared, I get that 3x squared on the outside. This leaves me with 3 divided by 3, which is 1. I had 4 x's. I divided 2 of them out. So that means I'm left with 2 x's here. Negative 33 divided by 3 would give me negative 11. I had 3 x's, and I divided 1 out, or 2 out, so I'm only left with 1. All right, I had 3. I took 2 out here, so that means there's 1 left inside. Then I have 84 divided by 3, which would give me 28. And then both of my x's got divided out, so there's no x on this term. So now, this got a whole lot easier to factor. So then what multiplies to give me positive 28 and adds to give me negative 11 would be negative 4 and negative 7, right? A negative times a negative multiplies to give me a positive. But then when I add those, I would get negative 11. So then when I set those equal to 0, I'm going to write on this page so I have a little bit more room. I'm going to set this equal to 0 since there's an x term. There is an x value or a solution in that term. Then I'm going to set x minus 4 equal to 0 and x minus 7 equal to 0. So if I solved this, divide by 3, I get x squared equals 0. When I take the square root of both sides, the square root of 0, there's no such thing as plus or minus 0. It's just 0. And then here I'd add 4, so I get x equals 4. And here I'd add 7, so x equals 7. So go ahead and pause the video and try those last 3. Remember, move everything to one side first, then see if there is a GCF that you can factor out to simplify the problem. All right, so if you pause the video, these are the answers that we should have gotten. So for number 13, I would factor an x out. So that would put an x on the outside, leaving me with x squared plus 16x plus 64. So what multiplies to give me 64 and adds to give me 16 would be 8 and 8. So then I set this x equal to 0, because that's one of my solutions. Then I set x plus 8 equal to 0, which just gives me x equals negative 8 for both of those solutions. For number 14, I had to move my 400x over first. So I have 4x cubed minus 400x. The GCF here would be 4x. So when I divided that out, I got 4x on the outside and then x squared minus 100 on the inside. We can think of the x squared minus 100 as x squared plus 0x minus 100 when we factor, which would give me x minus 10x plus 10 with that 4x still on the outside. So then when I set all of my terms, including this 4x equal to 0, I get x equals 0, x equals 10, and x equals negative 10 as my solutions. Then number 15, all of my terms were already on one side, so then I did my GCF. My GCF here was 10x, so when I divided everything, when I factored out that 10x, I was left with x squared plus 2x minus 48. I can factor that. What multiplies to give me negative 48 and adds to give me positive 2. I needed positive 8 and negative 6, right? Since my adding was positive, that means my bigger number needed to be positive. So negative 6 times 8 is negative 48. Negative 6 plus 8 is positive 2. So then when I set all of my factors equal to 0, I got x equals 0, x equals negative 8, and x equals 6. So hopefully this was a good refresher on factoring, and you can complete the back of this paper on your own. So this back of this sheet is going to be your homework or your assignment for this, and then you can check your solutions once you're done.